The entire universe is an electromagnetic phenomenon growing at the speed of light, warranting renewed thinking about the true nature of dark energy, dark matter and topology of the universe. The Hubble constant appears to be a self-contained number. However, by extending calculations with the current Hubble constant and the estimated age of the universe, it turns out that the entire universe is in fact inflating exactly at the speed of light. The purpose of this presentation is to reveal the links between the Hubble constant and the rate of expansion of the universe. We further discuss how the results fit into the standard Lambda-CDM model. Scientists now measure the Hubble constant at around 70 plus or minus 3 km per second/mpc. This corresponds to 21.47 plus or minus 0.92 km per second/million light years. The age of the universe is generally estimated at 13.8 billion years. The expansion rate of the universe is therefore calculated at 296,286 plus or minus 12,696 km per second, i.e. 283,590 km per second to 308,982 km per second. The speed of light in vacuum is known to be 299,792.458 km per second, corresponds to 70.82 km per second/mpc. It agrees well with the measured expansion rate of the entire universe space. If the entire universe has been expanding at a constant speed of light, it can be shown mathematically that the apparent speed of a celestial body, looking back in time, in percent of the speed of light, as seen by an observer, must be equal to its relative distance, in percent of the current distance of the universe from the Big Bang singularity origin. Based on this assumption, the redshift z values are calculated as shown on the next slide. Please note that all the calculations are basing on relative scales, both in terms of relative distances and relative separation speeds. The calculated redshift, relativistic adjusted, z values are closely agreeing with the observed Hubble redshifts. Extrapolating table S1 results further support the postulate that the cosmos as a whole has been growing at a constant speed of light since the infant universe. With the special relativity's notion that no object can be propelled with finite amount of energy to the speed of light, it is not unreasonable to infer that the expansion of the entire universe is in a form of electromagnetic wave propagation. A renewed thinking to consider the entire universe as a gigantic block of electromagnetic energy. The difference between the mass-energy equivalence, E equals mc square, of this gigantic block of electromagnetic energy and that of all celestial objects explains the mass-energy equivalence of all dark matters in the universe. The CMB recombination is predicted by the standard Lambda-CDM model to have occurred when the universe was about 380,000 years old, following the rapid inflation phase. We are able to detect CMB, electromagnetic wave, around us today because non-CMBs have been radiating concurrently with CMB at the same speed ever since. Given that both CMB and non-CMBs originated from the same mass-energy source at the recombination stage, this shouldn't come as a complete surprise. In contrast to the conventional Lambda-CDM model, the universe's expansion is not mechanically fueled under our new view. Instead, the expansion of the universe is better to be explained as an electromagnetic radiation. The assumption that dark energy drives space and matters apart is therefore no longer required.